Hello students, myself Dr. Pramod Kumar Shivajirao Hirai. I'm professor and head of the Department of Geography, HPT Arts and Arvake Science College Nasik. Today, I'm going to introduce you with bivariate correlation and regression. In chapter number 2, we discussed the organization and summary description of data concerning a single variable. A great deal of geographical analysis involves studying the relationship between two or more variables. Observations on two or more variables are often recorded for individual sampling units. For example, the height and weight of individuals, or the number of goals scored by and against a team. By studying such bivariate or sometimes multivariate data, one typically wishes to discover if a relationship exists between the variables, how strong the relationship appears to be, and whether one variable of primary interest can be effectively predicted from information on the values of other variables. To illustrate the concept, we restrict our attention to a simplest case where only two characteristics are observed on individual sampling units. Some of the examples are the height and weight of individuals, amount of rainfall and crop production of agriculture farms, smoking habits and lung capacity of adult males, average daily carbohydrate intake and protein intake of 10-year-old children, the age of an aircraft and the time required for repairs. This section focuses on those statistical techniques that enable us to measure and determine strength of statistical relationship between two variables. A number of different methods of correlation analysis are available to us. However, we'll be studying only one. Before that, let's learn about scatter graph and scatter diagram and its relation with the correlation. Scatter graph or scatter diagram and its relation with correlation. In this section, we are going to learn the idea of correlation and in particular to look at the technique known as Pearson's product moment correlation coefficient. Correlation is one of the most widely used statistical techniques in geography. It is used to examine degree of relationship between two numerical variables. When two variables, for example, town size and number of shops, increase or decrease together, this is known as positive correlation, where one variable increases as the other decreases. For example, increasing altitude with decreasing temperature is known as a negative correlation. The table below shows some of the possible relationships. In this table, there are three columns. In column number 1, we have variable 1. In column number 2, we have variable 2. And in column number 3, relationship. Let's see the first row. That is the size of settlement and the number of shops. The relationship is positive as the population of the settlement increases, so too does the number of shops. The variable temperature has its relation with altitude and its relationship is negative. Increasing height means decreasing temperature. There is relation between age of car and price of car. Its relationship is negative. The older the car, the lower the price. Next could be water pressure and depth of water. Its relationship is positive. The deeper the water, the more the pressure there is. And the last one, where no relationship exists between length of hair and physical strength. The length of hair does not affect an individual's strength. The scatter graph can show the relation between the variables. The value of variables are plotted on a graph as a series of dots, and then it is often possible to draw a best fit line through the plotted points, leaving roughly the same number of points on either side of line. In most cases, one variable will be dependent on the other. For example, if we look at the graph, the temperature is dependent on altitude, not the other way around. Altitude is not dependent on temperature. If we want to draw this as a graph, the dependent variable, in this case temperature, is always put on y-axis, and the other variable, in this case altitude, along the x-axis. The other variable is called the independent variable. In order to set up the scatter graph the right way around, we write the statement in the form: one variable is dependent on the other variable. For example, temperature is dependent on altitude, where the vertical axis is the y-axis and horizontal axis is the x-axis. Temperature is plotted on y-axis and altitude is on x-axis. The variable on the left of the statement always goes on a vertical axis, that is the y-axis of the graph. The variable on the right always goes on the horizontal axis, that is the x-axis of the graph. Therefore, the axis of the scatter graph will look like this. All we need to do is to plot the points on the graph using these two axes to get our scatter graph. Now these are the graphs that show some best fit lines for positive, that is the left diagram, negative, that is the middle diagram, and no correlation, that is the extreme right diagram. The scatter diagram provides a visual impression of the nature of the relation between x and y values in a bivariate data set. In a great many cases, the points appear to band around the straight line. Our visual impression of closeness of the scatter to a linear relation can be quantified by calculating a numerical measure called correlation coefficient. The correlation coefficient is denoted by R. It is a measure of strength of linear relation between the x and y variables. Before introducing its formula, we outlined some important features of correlation coefficient and discuss the manner in which it serves to measure the strength of linear relation. The value of R is always between -1 and +1. The magnitude of R indicates the strength of a linear relationship, whereas its sign indicates the direction. A high numerical value of r, that is, the value close to -1 and +1, represents a strong linear relationship. A value of r close to 0 means that the linear association is very weak. Let's see something about the regression analysis. Regression analysis consists the study of relationship between quantitative variables with the object of identifying, estimating, and validating relationship. The estimated relationship can then be used to predict one variable from the value of the other variables. In this chapter, we will learn regression analysis with specific reference to a straight line model, that is, linear regression equation in the beginning, and then we'll be learning about the other models. This is the declaration of my presentation, and I thank you all for paying your attention. Thank you very much.